Very warm welcome to Admiral Puri, who is going to speak to us on a very important subject of role of technology in Make in India. Now, it is a very important subject, obviously, goes without saying, because future wars are going to be fought differently. And they're going to be far more different to what we see today. Far more technical in nature, and equipment will make a lot of difference in that. The weaponry will make a lot of difference in that. And they will be technically most critically developed in case you have to succeed. Now, Indians call for Make in India, and technology transfer is obviously for that reason most appropriate and most timely. Actually, we should have done it long time back, but we kept on relying on easy way out and kept on depending on the weaponry which was supplied to us by initially during '62 by Americans a little bit, and later on by the Russian and all that while. So we never really gave a very serious thought to this. Now that we have come to a stage when 70% of our equipment is being imported by us, we are finding that you cannot bear with the cost. That is one. And number two, the problem is that when it comes to the real crunch time, you find that the people who are supplying you those weaponry, and that is, say for example, the Russians in this case, which they have done over a very long while. Now, of course, we have diversified. They really fleeced you for money. The spare parts were costing 10 times more cost, and then they were not given to you in time because they tried to apply pressure on you for different kinds of things like accepting a ceasefire and things of that kind. So it was never a good solution, but it was a solution which India had to adopt under the circumstances. Now a time has certainly come for India to make its own weapon systems, but of course you cannot do it all on your own. It has to be done with the help of the outsiders. I will not question Admiral Puri's idea. He is very much confident about India's capability to develop own technology through the DRDO route. But whatever the route we adopt, the fact is that we need these weapons and we need this weapon system to be developed by our own selves with the help of course, our own people are with the help of outsiders, but we have to follow that route. Now, we have a very competent and no person better than actually Admiral Puri in these services to talk on this subject. He is a very seasoned sailor. He has commanded the Eastern, the Andaman Command. He's been in the IDS, Integrated Defense Staff. Then he has also been also the DRDO guide and philosopher for very many years, and he is very convinced, thoroughly convinced about India's capabilities to develop our own weapon systems, of course with a little bit of help from here and there. So I leave you to him for his talk. He has a presentation to give, and after that we'll have a question answer session. So on to Admiral Puri. Thank you.
General Vij, Director of VIF, ladies and gentlemen. I will talk today on technology in Make in India. How important it is to be able to develop our own technology and Make in India and not do what we have been doing for the last 60 years, which is what can be termed as a regime of licensed production, often sold to the country as transfer of technology. I believe that is not a correct thing that has happened, and now much of the problems that we face is because the industry has grown on license production hardly developed its own technology, hardly developed its own research and development. And so when a separate agency develops technology, it is difficult for that agency to be able to productionize what it produces through such an industry. This will be, I will cover it in great detail and explain myself as we go through this presentation. If you see the emerging domains of warfare, principles of war and strategy have remained relatively static. What has changed is the technology of war, especially with the coming on of the principles of the revolution in military affairs, which requires a systems of system view, net-centric warfare, joint engagement capability, additional dimensions to war of space and cyberspace. This makes the technology requirements of defense highly diverse. It ranges from the Indian Armed Forces want biodigesters at one end of their requirements and ballistic missiles at the other end of their requirements. In between there are aircraft, whole type of missiles, electro-optic systems, radars and so on and so forth. This research today in India is being, I will be talking about DRDO, not because DRDO is necessarily the only R&D organization, but as far as defense is concerned, I think 90-95% of the R&D goes on only in DRDO. There is the other major research organizations in the country are the Department of Space and the Department of Atomic Energy. The three do collaborate, but the major work as far as the defense R&D is concerned, it comes from DRDO. Then why do we need to develop military technology in India? Why can't we continue to keep buying? And my reasons are what? First of all, we have already entered what I call the triple trap syndrome. And a phrase coined by my friend Dr. Siddhartha, and I have used it many times in many presentations. Firstly, what is developed abroad will not suit threat-specific requirements, be it electronic warfare systems or other systems. Somewhere the environmental parameters won't match, somewhere the operational parameters won't match. And when we want to make this equipment relevant to our environment, the foreign OEM doesn't have time for you. It costs money, it costs time, and it costs a lot of effort. So what we'll end up is doing half the time setting that equipment to our requirements. What is suitable will be denied. And there is, on this again, I will ask Dr. Siddhartha to say a few lines towards the end of the talk. We have the Wassenaar Agreement, we have export control laws, and whole of other laws which are especially become applicable to us after our Pokhran explosion. This has seriously resulted in cutting off of cutting-edge technologies. To India today, there is limits to what technology can be sold to India. If you want an infrared detector of a certain pixel range, say 500 or 1000, which is under development in advanced countries, that is simply not available. We can't get it from anywhere in the world. You'll have to do it yourself. What is not denied will simply become unaffordable, and that's the situation we are in today. So what is transfer of technology for foreign OEM further is hardly a feasible proposition, as our experience shows, and this I will be covering in a little detail in the later half of my presentation. And without a calculated degree of invulnerability to military technology denial, an independent foreign policy is just not possible. And we are in that situation also. For critical arms, we are dependent on the Soviet Union. Now we have become dependent also on the United States. We are dependent on France. I can name half a dozen or more countries to whom we are dependent upon. And so therefore it becomes difficult to follow an independent foreign policy. And finally, imports at the current level, as the director mentioned, are just unaffordable. Not in the current defense budgets. We probably need to double or even triple our defense budget if we have to meet our requirements through imports. What are the characteristics of the defense sector in India? And this, as I have already stated, licensed production of foreign equipment covered by under buy and make Indian categories of the defense procurement procedure. Funny, I mean, it is surprising to me actually. This procedure started, their origin started somewhere in 2002 after the Kargil operations, where there was a huge hue and cry, a lot of delay in supplying equipment and all that. So to increase the velocity of our purchases, these procedures were brought into focus and new procedures are adopted. And in these procedures, DRDO has been excluded from developing high technology, conventional arms and equipment. The first priority is to buy. The second priority is to buy and make from foreign sources. The third priority is to buy and make with Indian sources, which has now been changed as late as in 2013 to buy and make Indian as the first priority. But that also is nothing else but licensed production. Because all that you require in buy and make Indian is 35% indigenous content, which will come from the shell of the equipment, the labor cost, etc. will be 35, and the key technology will still keep coming from outside. So very little difference has taken place. Even it's a very good bureaucratic method of saying buy and make Indian, but nothing very much Indian has taken place. DRDO remains out of the loop. And they are the third priority of make if both these methods don't succeed. Whereas in my view, for a country like India, that should be our first priority. First assess what we can make. So there is often technology available, but we go and buy it. Anyway, the OEM is paid for in this method, the OEM is paid for transfer of technology and license. OEM supplies manufacturing technology. OEM seldom provides or can provide technology underlying to manufacture the complex systems. And this again I will explain why it is very difficult to be, this phrase transfer of technology in my way is a false phrase. And that I will come to as to why I say so. In this method, a portion of the platform continues to be supplied by the original equipment manufacturer. There is no capability to upgrade the platform, and continuous import is required for maintenance, repair and overhaul, and this itself is becoming unaffordable. Apart from the time delays that take place, as it was mentioned, that the spares may start costing 10 times the amount when they know they are critical to you, and there is no limit. I mean, you are in a what I call a single vendor situation. There are no two suppliers available. So whatever he charges, and if there is a contingency on, you will pay whatever he will ask for. The other characteristics are that the cost of indigenous equipment rises. An imported Su-30, for example, at a point in time, I mean, I do not know what the cost today was, about 230 crores. The cost of an indigenous Su-30 was high. Last 70 years, we have followed this route, or maybe 60 years, we have just followed this route. There is no indigenous combat aircraft capability developed in the country except under the LCA, and no indigenous capability to design, develop and hold our own IP is available except through the LCA project and other indigenous projects that we have taken up. All these projects give us neither design capability, nor a development capability, nor capacity to hold an IP, and we always wonder why are defense exports so low? We have nothing exportable. The first item that you need when you want to export something is that you hold the IPR over that item. If you don't hold the IPR, you can't export it. So you may be manufacturing a lot, but there is nothing exportable except what has come out of the DRDO stable. And I'll come to that. So what do we need to do? We need to establish an ecosystem for designing, development and production. creating IPRs. Foreign components probably can go into these systems, could be even 30% or 40% and more, if the cost of production of these components within the country is going to be extremely high. But since you hold the designs of the components that you're getting over, it is always possible to substitute. You don't land up in the situation that you are with license production. And Indian companies would be able to continuously upgrade. To sum up then, TOT from foreign OEM is restricted to manufacturing transfers of technology, what is called build-to-print capability. IPR is not transfer, systems neither upgradable nor exportable. Transfer of technology of SKT, CKT systems is all that you get. No capability build-up, even major maintenance requires OEM assistance. And now I will consider what is the impact of all this. So there is really no alternate but to have indigenous technology development. Knowledge is the source of power, and uncertainty of information and its availability becomes the most relevant cause to invest in knowledge. Sharing of knowledge and strategically important international collaborations take place among equals or near equals based on contemporary strength and, most important, strategic alliances. Otherwise, the Vasana arrangement applies. And we have no strategic alliances. Today, Pakistan has got a strategic alliance with China. So they will get what they want. Whatever he can get. We have no such alliance with them. Acquisition of core technologies needed could only be achieved by pursuing R&D activities, as no country will share frontline technologies which are difficult to transfer anyway. R&D activities work silently in the background of the economic development. So where do we stand as far as technology development is concerned? Many systems have been developed, delivered, inducted and are in production. They are missiles, they are command and control systems, they are electronic combat systems, radars, electronic warfare equipment, electro-optics, lasers, engineer stores. I mean, there's a range of equipment that is under manufacture. Unfortunately, all this happened in the 80s and the 90s. When we launched the IGMDP program, when we launched the LCA program, when we launched the MBT program. Major program was launched. They have taken time to succeed, but the first of type of a system anywhere in the world does not take less time than what we have taken. And we have taken this much time with an industrial base much smaller than any of the developed countries that have developed these items. And whereas the nation should have been clapping today at the development of LCA, in whatever shape the MBT has come and all that, we are cursing the DRDO. And the net result of all this, we are losing scientists at a rate which we will regret one day. As far as private sector participation in defense sector, as a result of technology development in India is what I would like to talk about, is starting from zero industrial base in 1958, nearly 1,000 small and medium scale industrial partners of DRDO have emerged since 2014, up to 2014. Enable both large industries and SMEs in the development of various systems and also in establishing test and evaluation facilities. The status as on today is that many of these industries are working as Tier 2 and Tier 3 industries. And what I mean by these Tier 2 and Tier 3 industries is, if you take a LCA program, for example, there is design, assembly, integration and service, which design has been done by DRDO, by ADA, DRDO, and number of about 100 agencies are involved in this first process of design, assembly, integration and service, HAL being a major partner. Then there are Tier 1 industries who make structures, fuel propulsion, pneumatics, all these systems, and they are all specialized systems in themselves. which all require a development effort. Then there are tier 2 industries and there are tier 3 industries. So there are a number of industries that have come up as a result of the LCA project, which is almost 70% indigenous today. And there is a Society for Indian Aviation Technologies, which is developed, having a membership of almost 1,000 industries over there, trying to develop all, which are now putting pressure on the government to increase the aerospace industry indigenously. Then there is, this just reflects what are the industrial partners of the DRDO today. There are 30 ordnance factories, 40 public sector units, 30 major private industries, and 1,000 approximately other industries. And this is all from the base 0. Defense R&D is a technology provider, therefore essentially it provides military technologies and what we call spin-off technologies. Technologies that can have civil use. And these technologies are transferred to the industry depending on their commercial viability between a program which is between DRDO and the FICCI. There are something like 500 technologies on offer, out of which 87 industrial agreements have been achieved, and I think about 40 technologies actually transferred and commercialized today. And this program started sometime in 2009. So we have many systems, as I was talking about. Akash I have shown over here. The production order of this system is something like 25,000 crores today, and it will come to much more. The total value of items that have been developed within the country, and some productionized, some awaiting production because of the lack of production capability in the country, is to the value of 1,75,000 crores today. Then the next type is just as an example, there is a thing called the explosive detection kit, which has been productionized both in India and the United States, and is used. It is an approved for Global Security Contingency Fund by the United States. So let me now come down to the process of Make Indian. What are the challenges that face us in transitioning from this licensed production regime to what I call a Make Indian regime? And both these processes, licensed production is what is Make in India today. What we are trying, if Make in India remains licensed production, that a lot of people come and produce, especially in the defense sector. I am not talking of the economic sector. But in the defense sector, if companies just come and make in India, it will be nothing better than licensed production. So it has to be designed and make in India, so that it is Make Indian, not Make in India, or Made Indian, or Design and Make in India. So if you are going to do that, what are the challenges Make Indian will face? Till date, not a single Make project has taken off. This process was first Make Indian was included in the defense procurement process in 2006. Till date, nothing has taken off. The disbursement of funds by MOD is a problem. Selection of the development agency, and this L1 basis is something that is a problem faced by the entire industry. You have got to take, if you're going to make high technology stuff, the technological capability of the industry as the prime focus in selection of a development partner, and not just costs. As per the current procedure, the IPR belongs to the MOD anyway. All these things are under discussion, and the next DPP is expected to solve these problems. Let me come to so if we are to develop technology, what is technology? Technology is not a simple, it's a simple word. And a lot of people say, we go abroad, we give concessions in climate change and all that, and then say there is going to be transformation. transfer of technology. What is this transfer of technology that is good? I have not seen any transfers of technology taking place really in that sense. Where we acquire a capability to manufacture a product from its raw material and then upgrade it ourselves. If we can upgrade it ourselves, then there is transfer of technology. But if you are dependent on everything from the OEM all the time, then there is no transfer of technology. And to transfer technology, it is not just hardware. You got to transfer the humanware requirements, the technoware requirements, the organizational requirements, and the infoware. These are difficult issues to transfer. You learn them. It takes countries 15, 20, 25 years to do all this, and to expect, because we have signed a contract that technology will get transferred, it doesn't happen. Next step. How is technology developed there? On top is the R&D, and it creates an existing body of scientific and technology knowledge in a database. That R&D is, and the knowledge base then is used in the first instance as to invent and produce an analytics design. Thereafter, and using this knowledge base, if this knowledge base is deficient to do this work, you go back to R&D and cover the gaps. From this process, you go into detailed design and testing and end up producing a prototype. The process is the same. You use your knowledge base on this area and then go back to R&D if this is deficient. The next is produce the item. And when you produce, what he produces is a prototype, and this fellow will have to produce, redesign to some extent to suit the production processes, and then produce the item. In this process, he contributes what I call this I, which is the contribution of the manufacturer to the process of manufacturing. And this happens when he takes a design, a prototype, and produces a design. Now, if your industry is not used to this process, all that happens is there is something already in production. You get a drawing with you, and then you just reproduce that drawing. You don't redesign, you do not know anything of, and that is a fundamental problem that we are landing up in today. LCA is a wonderful aircraft. It is a Mirage 2000 plus, no press wala is talking about it. There are enough lobbies in the country to ensure that we never clap in the LCA. All that is talked about, there is a time overrun and there is a cost overrun. And both these are myths. There has neither been a time overrun nor been a cost overrun. I like to explain it in a few words. LCA was sanctioned, the project was thought of in 1983, and a grant of 583 crores given to develop a project definition document. At that point in time, we didn't make gudgeon pins for scooters, forget about making an aircraft. Faculties were set up in universities. Wind tunnels were set up. Facilities for testing were set up. Aeronautical engineers were created. And a project definition document drawn up in 1990. The project definition document said we can produce an aircraft in 8 years, 7 to 8 years. It will cost us 4,000 crores. But the Government of India and the Indian Air Force sat tight over this document. Number of committees went through, and after 3 years of indecision, a decision came that you can manufacture this aircraft, but only do the aircraft. The weaponization part of it, we will do after we have seen a flying aircraft. The proposal was 2,000 crores for the flying aircraft, 2,000 crores for the weaponization, avionics, etc. that would need to go with it into the aircraft. With the result, after early 2004, end 2003 the sanctions came, the first aircraft flew in 2001. That is only 8th year it flew. But then a lot of press statements came from knowledgeable people that this is only a flight platform. Where is the weaponization? in the manner in which you gave the sanctions, how do you expect him to do weaponization? He needed another 2,000 crores for it. 2,000 crores were then sanctioned in 1990, in 2001 end, rather 2002. It took them another 7 years to weaponize thereafter. The things that could have gone on in parallel went on. As far as cost overrun is concerned, in the 2,000 crores that was sanctioned, it was sanctioned for 2 prototypes. The Aeronautical Development Establishment produced 4. Where is the cost overrun? And the total cost of development of this aircraft is $1.2 billion. I want to know which country in the world has produced an aircraft of this complexity and in that cost. So whereas this country should have been proud of what it has done, we have everybody criticizing. And we have got a lovely press. There are a lot of lobbyists and everyone else over there to ensure that every time something happens on the LCA, a big article comes out that 83 this happened, so much cost overrun, and I think Times of India is the grandmaster at that. Right then. So then this is the process. So what is the system as a result of LCA, all these projects that has, ecosystem that is developed within the DRDO? That DRDO together with Department of Space in some cases and the academia will produce the initial proof of concept of the design that they have thought. Thereafter, they produce the prototype. Thereafter, it goes to industry. This process for the first of a type of a complex system like an aircraft or a missile like the Akash system, nowhere in the world takes less than 20-25 years. But Mark II, mind you, will come out in 4 to 5 years. Because the fundamental this technology base only needs to be upgraded slightly. What you have developed here will, LCA took us, has taken all that about, actual development time and testing all that time is about 15 years. LCA has taken that much time. But the advanced multi-role combat aircraft, if you were to design and make ourselves, will not take that much time. Its cost will probably be lower. But yet, what we find is SGFA, Rafale, what else? And we can continue to do that. The cost will be paid by the country, and then and the greater cost will be in your preparedness to fight. Even in the Arjun, for example, Arjun Mark II, the Army indicated 82 improvements in the Arjun Mark II. All those improvements were completed in 2 years. Now the weight has gone up, and that was told that if you do all this, the weight will go up. So anyway, those things are there in the system, and the way we go about quantifying all our technologies is, what is the technological readiness level at the start of a project? Are we at the level of basic research? Are we at the level of basic research? That is TRL 1 to 2. This is roughly done between laboratories and the academia. Are we at lab feasibility demonstration stage, which is TRL 2, 3 and 4? This is largely done again between the demo lab and the academia. Are we at technology development stage, TRL 4 to 5? In most of our engineering equipment development today, we are at this stage. We are already, we don't have to do this work. If you want to design bridges, if you want to design vehicles, if you want to design tanks for that matter, we are already at this stage. So while we may have taken number of years when we started off, but today we are at a much better stage. And but not to exploit it now will bring us back over here. And we'll pay a price for it. At least our children will. Next comes technology demonstration. From this stage onwards, the industry should get involved. And then you do systems development, and then you do operation support, TRL 7, TRL 8, 29. Time frame from here to here can be as little as 4 to 5 years. Many systems today, the gun system that is being developed, the time frame for development is only 3 years. It is a different matter for that. For 20 years we didn't give them an order to develop, although the designs were being made. But once you got it, go ahead, it is 3 years. And I think instead of 3, it may take 4, but that's all that will happen. So R&D process to meet mission capability need, I want to first come down to everything in this process that we do depends on the mission capability needs of the armed forces. And making mission capability needs is also a technology. It is not something that we can sit down in rooms, read brochures and write that this is my equipment specification and we hope to get that equipment at the end of the day. You write complete mission specification and that guides basic research, that guides this, that guides this, that guides this. And this again basically is the earlier diagrams. It shows you what that science and technology is done here. And when you do license production, or you do an FDI, or for that matter, what we call these offsets, what you are doing is going straight to the industry, giving him a build-to-print diagram. No technology base will ever get built up through this FDI or through, lest you have in the capacity to leverage your FDI in the manner in which we did when the first HGW project was made. I'll come to that if I have time. On the way the Koreans went about developing their high-speed trains, if you follow that model, yes, it is possible. But for that we need skills in negotiation which don't exist in the Ministry of Defense. So you need mission capability technology also. And to have this capability, this is my own functional diagram, which I made while I was in service, which says that where do mission capabilities should emerge, and especially if there were to be RMA compliant joint mission capabilities. This diagram shows this is the political sphere of the government of India. It is your cabinet, council of ministers, upper house of parliament, lower house of parliament. This is the military sphere, which has got the 3 armed forces, the commands and all that. Connecting them, what you see within D is the higher defense organization. It is the efficient functioning of the higher defense organization that produces mission capabilities. Unfortunately, as per the Kargil Committee report, this is a weak organization. These organizations were created as a result, till then nothing existed. But as many things in the government of India, all these work in silos. You get very little. And therefore, this is a characteristic of the high defense organization. It is part of the political organization of the country and not the military organization of the country. And there is a theoretical basis to it. I won't have time to explain that. But the net result of that is the Army, the Navy and the Air Force independently do their plan. There is hardly any joint plan possible when you have this system efficient and working. It is in the interest of the armed forces first to ensure that this comes up. Because if it doesn't, we will never have joint plan. Space capability and cyberspace capability will especially suffer the most. I mean, this is what that mission capability does. The mission over here is to produce precision attack capability, long range precision. To achieve that, you need these goals to be achieved. efficient, timely, high quality surveillance, reporting, target designation, assessment information and all that and all that. To have these are my functional capabilities. The functional capability is required, and then what are the key technologies? This is sort of an analysis which you find in the open literature today as far as the United States is concerned, in their warfighting science and technology documents, that we have to learn to create. It requires experimentation, it requires some amount of basic research work before you get to these figures. I mean, this is a continuation, another goal to achieve the same, and after such an analysis, you are in a position to produce such a plan which on top gives the capability to be developed, on the bottom gives the technology demonstrators that will be developed to fulfill these capabilities. This gives what I was talking about, the technology readiness level, the baseline technology readiness level, are you at technology 1, 2, 3 or 4 or 5, how this technology readiness level will grow, and with each growth, how the capability will cumulatively develop. And to develop this capability, for example, here the plan started in 1995, it will go on till 2020 maybe. But there is a 15-year plan. Now till you do this long-term planning, technology development in time, to your time frame, becomes difficult. And in our system, it is, I mean, there is no point criticizing too much, but fact is that we need to improve it a lot. And this itself, I mean, we just shouldn't keep talking technology, we should worry about our own systems also. The second thing is, I mean, this is almost the last slide that I have. The Chinese model of development, how they have developed so quickly, has been, firstly they were mostly by imports. Stage 2 was import critical parts only. For example, they took the Su-30, imported it completely. But even while Su-30 contract was going on, they started developing the critical parts. And by the time I think they had fitted 100 aircraft, they had fully localized Su-30. And they told the Russians, we can now terminate the contract. Thank you. We have been manufacturing Su-30 for many, many more years. And we are at 51% indigenous content in planning. There is no reason why we couldn't have done all that. Provided we involved our R&D to do the component development, provided there was synergy, and provided that the user pushed for it. Finally, indigenous technologies, so that now you have the J10, J11, J31, God knows how many, I think they're the largest number of fighter programs in the world, all through indigenous technology. We have the LCA, but we want to not give up the LCA and say now we will start going to HDFA to Russia and do joint research where the aircraft is already flying. What joint research will you do? So let's not fool ourselves or fool the public, but and then they are able to export. We have, as I mentioned in the earlier, very little exported. Yes, evolution of warfare. Today we should be really thinking of these systems. Hypersonic weapons, what do we call it? Robotic soldier, and a number of things. By the way, R&D is thinking about all that. I have drawn up the long-term technology plan for DRDO only last year. I worked a year and a half over that plan, and I saw the laboratories were up to it. They were thinking, but they have no mandate, no funding, so they keep thinking, doing basic research, for which is cost very little. And whatever technology development funding is available within the DRDO, they keep developing it. But to go to mission mode and develop a product for the armed forces in our system need to raise a need. And if the need doesn't come, like it has happened for the gun, for 20 years, there is no gun. And then we can keep howling every second day that we are short of guns. So gentlemen, this is my take on Make in India. What we have to do is not just make in India, but design and make in India. The probability is that in most areas, it is not development of technology that is likely to be the bottleneck. Yeah, there are some critical areas where we have difficulty. We have difficulty in propulsion systems, especially gas turbine propulsion systems. We have difficulty in seeker heads. There are areas where we have to make improvement, but those are known areas. The problem is going to be manufacture. With this Wassenaar agreement in place now, it is becoming more and more difficult to get the type of manufacturing machinery that you require for high technology manufacture. And perhaps when we want to do bullet train and all that, we should leverage our strength over there to say we will make a bullet train with you, we'll pay you everything, but you give us so and so, so and so, so and so manufacturing capability. And do not manufacture it, all critical components in wherever that bullet train is going to come from, and say you make the 60% by value you make, we will make that 40%. And 40% will require all the machinery and all that which is prohibited under the Wassenaar Agreement. So if that is going to be our case. So in my opinions, gentlemen, FDI, offsets, all that is not a solution to our, it is very often simplistically assumed, unfortunately, by policymakers too, that FDI will bring in technology. Nothing can be further from the truth. All foreign defense majors have protested continuously against offsets and have pressurized India into diluting offset requirements one way or the other. I was in the system when offset requirements were first made. Requirement was direct offsets. If you are giving me an aircraft, then offset will be on components in that aircraft. The technology to make them. Mostly, the type of pressures your industry is not capable. Yes, of course my industry is not capable, but that's what offsets are all there for. And we keep diluting offsets. So putting a contract and saying there will be transfer of technology, offsets and all that is all very good. But who's going to implement all that? Then, while they may cite logistical or other reasons, the real anxiety is about sharing and losing control over technology. Especially if the offset partner is a public sector company whose bargaining power is greater than a private sector junior. They will be more comfortable with Reliance, with a junior partnership than with Reliance. So as Reliance, he will make profit even when he makes 60% or 40%. India's confidence in outright flow is a facile equation between foreign investment, local manufacturing and technology flow. The key requirement is not money, but technology, and technology transfer is elusive. It requires not just a clause in a contract, but in the recipients taking determined measures to ensure acquisition and absorption of technology. India has been singularly poor at this. Right, gentlemen? This is all that I have to say. I'll be happy to take any questions that you may have. Thank you.